So convex mirror, right? In this case, we don't have any positions at all, because it is in front of the mirror, where the locations of this mirror is behind the mirror. Correct. So, but obviously the reflecting surface is going to be the curvature. So I take only two cases here. Number one, I am going to place the object at infinity. Number two, I am going to place the object at finite distance. That is the only case which we have. Okay. So when I place an object at infinity, the light ray is going to pass through parallel to the principal axis, and it is going to reflect back like this. This diverge there. So this is going to be the image formation at focus. So what is going to be the characteristics here? The images are always going to be virtual, erect, diminished. In this case, it is going to be what? Point sized at virtual focus. Yes, so this is going to be when the object is at infinity. Suppose when the object is at finite distance, right? So let me take somewhere here, right? One light ray, it is going to be parallel to the principal axis. It is going to cut the focus of this point. Another ray, if I am passing it through pole, so these two rays are going to meet somewhere. Yes, so this is where the image is going to be formed. Yes or no? Yes, so what are the characteristics going to be? Virtual, erect, diminished. Yes, between P and virtual focus. Okay, so these are the image characteristics of a convex mirror. Is that clear? And we were discussing on applications of concave and convex mirrors also. Right, concave mirror headlamps, where the light has to be focused at a particular point. Yes, where we will see with the convex mirrors, where the field area is going to be larger, rear view mirrors, side view mirrors, and also the hairpin bend mirrors. Yes, so where we require more amount of area to be covered. Clear? So these are the cases of concave and convex mirrors. Is that clear? Any doubts so far?